So far, we have seen that derivatives behave very well with the sum and difference of functions. Now, with the product and quotient of functions, that is not the case. So let me write down a warning. Derivatives do not respect the multiplication nor division of functions. Okay, let me box it. So what am I trying to say here? So ddx of f of x times g of x equal ddx f of x times ddx g of x. Okay, this is absolutely false. Okay, so let me make sure that this doesn't get recorded. Okay, this is absolutely false. And when I do the derivative of a quotient, f of x divided by g of x, okay, one would wish that this is ddx f of x divided by ddx g of x, okay. So this also happens to be the total lie, okay. So those are not the correct formulas. Whoops, someone forgot. There we go. So correct formula, and let me take that ugly formula out of my view. So ddx of the product, okay, is equal to the derivative of the first times the second without derivative plus the first without derivative times the derivative of the second. Okay. And this is the formula. So you can say it like a song, like it's the derivative of the first times the second without derivative plus the first without derivative times the second with derivative. Okay, let's see how this works. Example. So let's find the derivative of 3x squared plus 2x plus 9 exponential of x. So df dx equals, and now notice here we have two functions, right? So it's ddx of the first times the second plus the first times the derivative of the second. Now here we have the exponential that is really nice, right? The derivative of the exponential is itself. And here it's a polynomial, which is not bad either. So this is 6x plus 2. So we have 6x plus 2 exponential of x plus 3x squared plus 2x plus 9 exponential of x. And remember, always simplify as much as you can. 3x squared plus 8x plus 11 exponential of x. Box it, and this is the derivative. Okay. Now, this is for the product. So what is the rule for the quotient? All right. So ddx f of x divided by g of x. Obviously, g of x shouldn't be 0, okay? So it's the derivative of the numerator times the denominator without derivative minus the numerator without derivative times the derivative of the denominator divided by the square of the denominator. Okay. This expression looks difficult to remember, but there is a trick to remember it. Okay. So the trick is practice, practice, practice. So let's start. Let's say we have f of x squared plus 3x minus 2 divided by negative 7x plus 5. Okay, you see clearly this is a quotient of two polynomials. So to compute f prime of x, I need to compute d dx of x squared plus 3x minus 2 times negative 7x plus 5 minus x squared plus 3x minus 2 times d dx minus 7x plus 5 divided by minus 7x plus 5 squared. Okay, so this is 2x plus 3 times minus 7x plus 5 minus x squared plus 3x minus 2 times minus 7. And this is divided by minus 7x plus 5 squared. Okay, and we don't leave it like this. We try to simplify. So this is minus 14x x squared, sorry. There we go. Plus 10x minus 21x plus 15 plus 7x squared plus 21x minus 14 divided by, and this we can leave, minus 7x plus 5 squared. Okay, so there's a simplification, the 21x. Okay. And this turns out negative 7x squared, you see, because of the x squares, plus 10x. And then I have 15 minus 14 plus 1 divided by minus 7x plus 5 squared. And we can leave it like this, box it, and done. Okay. More examples. So f of x, the exponential of x divided by x to the power 3. It's always good to have an exponential. So f prime of x is d dx exponential of x times x to the power 3 minus ex d dx exponent, x to the power 3 divided by x to the power 3 squared. All right, so this is ex x cubed minus ex 3x squared divided by x to the power 6. So we factor the exponential, and I have x to the power 3 minus 3x to the power 2 divided by x to the power 6. Simplify x squared. This is ex x minus 3 divided by x to the power 4. Okay. We could also, you see, we could also do this one if you don't want to remember the quotient rule, although I recommend you to memorize it, okay? You could always derive this from the product rule, okay? Because if we notice, this is the exponential of x times 1 over x to the power 3, or this is ex times x to the negative 3. So we could do the product rule instead. Okay, so this is d dx ex x to the negative 3 plus ex times d dx x to the negative 3. So this is ex x to the negative 3 plus ex times negative 3 x to the negative 4. Okay, so this is ex, and then I have here 1 over x to the power 3 minus 3 x to the power 4. Okay. Which after simplifying should be the same we had before. Okay.